Alright, so this problem is a fairly straightforward one, but it makes sure that you're being careful about how you apply Newton's second law in a situation where acceleration is happening. So we have a package, and we have to first draw and label the forces that are acting on it. Right? So our box, we know from the description that it's attached to a rope that hangs from a helicopter. So there's a tension force or rope force or something like that, right? The key is to indicate that it's the rope that does it. It's not the helicopter motor or something that causes it to do that. It's specifically a rope, so it should be something related to a tension. Then, right, the package has mass, 70 kilograms, so there must also be a weight force. And that's it, right? There's no surfaces that it's in contact with, so there's no normal force or friction. There's no spring, so there's no spring force. It says neglect air resistance, so we don't draw a drag force in. Right? So that's it. That's part A. Right? Part B, determine the tension in the rope. By now, this should be sort of second nature. After you draw a free body diagram, Newton's laws are what you should use. So I look at my free body diagram and I say I only have vertical forces. So this net force in the vertical direction equals the mass times the vertical acceleration. All right, we're asked to find the tension. So tension is positive, weight is negative, right? And our acceleration is in the problem statement. So the tension is mg, that's the weight, plus ma. And that's just mg plus a. So now we just plug in the numbers. 70 kilograms, g is 9.8, and a is 5.0. Right? And if you punch that all into your calculator correctly, you get 1,050 newtons. And that's part B. All right, part C is a little bit trickier because you can't do it just in one line. Right? It's a couple different steps. Like what happens is the helicopter is moving upward and the string is cut. So initially, the box and the helicopter have the same velocity, but after that, the helicopter keeps accelerating upward, and the box only has one force acting on it, the weight force, so it accelerates downward due to gravity. But the key is that the initial velocity is the same for both. So we can figure out how far they both travel in 2 seconds, and then after that, then you can figure out how far they are apart. So it's going to be kinematics. We're going to do it twice. So first we're going to describe the helicopter. So we want to figure out the distance. We need to do in a kinematics equation that involves distance, right? So it can't be the first one that doesn't involve a distance traveled at all, just as velocity and acceleration. And we're given information about time, so I don't want to pick the third one that doesn't involve time. So I'm going to say that the distance we travel equals the initial position plus the initial velocity times time plus 1/2 a t squared. So we're going to say the helicopter is at position 0. Why not, right? The initial velocity is 30, 2 seconds pass. The acceleration, now it's a little bit larger, apparently got rid of some of that weight, and the time is 2 squared. Right? So you can punch all that in, and if you do that, you get that the helicopter travels 70.4 meters in that time. Right? So now, what about the box, the package? Same idea, right? We still care about distance, and all the other stuff that I described is still the same. But there's a couple things to note. First of all, the rope is 5 meters long. That means the box starts 5 meters below, hence -5, where the helicopter is. Then, initial velocity is the same. And the acceleration, once you get rid of the tension, the only acceleration is due to that of gravity. Oops. So -9.8, and then t squared. Right? And so the things that can be tricky are remembering the box starts 5 meters below and remembering that gravity's acceleration is negative. If you get those 2 bits, you're probably fine. And if you calculate this out, you get that the box travels 35.4 meters. And so the distance between them is going to be the difference between those numbers, right? 70.4 minus 35.4 is exactly 35 meters, right? And that's your answer.